A person at the top of a building of a height 30 meters throws a ball with an initial velocity of 10 meters per second upward. And then as the ball goes upward, then reach a turning point and come back, and then until it reaches the ground. Now the question is, in part A, you need to find the time by which it arrives the maximum height, and part B, what is the maximum height it reaches. And then when it comes back at the same level of the thrower, it's required to find the velocity of the ball. And then part D, it's required to find the position and velocity of the ball after time of a flight of 3 seconds. And finally, what is the ball's velocity just before it hits the ground? Well, this figure shows the path of the ball and the turning point at B when it comes back to C and then goes back to the point D and then E. The first part of the problem, we need to find what is the time at the top of the maximum height from the top of the building. Simply, in this problem, the final velocity here, as at the turning point, of course, the ball is going to change its velocity here from up to down. So it has to pass through a velocity of 0. That's why at the top, at point B, at the turning point, the velocity is B. This is considered as a final velocity. The initial velocity is 10 meters with a positive sign as the ball goes up, and the time at point B is required. Simply by putting these values of the velocity VB equals 0 and V initial equal 10 in the problem, and then we might be able to get the time of 1 second at the maximum height. So if it takes 1 second to reach the maximum height, obviously if it comes back to the same level of the thrower at point C, the time is double that. So we're going to get 2 seconds for the trip from A up, then going back to the same level at A. Now to find the maximum height, as the purple line indicates, we have to check the information we have. We have an initial velocity of 10 meters per second, and it's required to find delta y from A to B. That represents the maximum height. Of course, the absolute value of this displacement is the maximum height. So, knowing this initial velocity and final velocity, and to obtain delta y, we use this equation and put the values, the available values, into this equation of velocity initial of 10, and also we put the final velocity of 0, and then we might be able to get delta y, and delta y in this problem is 5 meters, and it turns out to be positive as expected because the ball is going upward. Now what is next? It's to know that the maximum height at point A is 5 meters, and this result shows that the displacement is positive, as I said before, as the ball moves from A to B. To find the velocity as the ball returns to the level of the hand of the thrower, there are more than one way of solving this problem. The easiest way is to start from point A and then come back again after it goes up and then down. From A to C, if you want to solve it from A to C, what we have an initial velocity of 10 meter per second and an unknown final velocity vc. So the final velocity is vc, applying the same relation as before, and the initial velocity is 10 meter per second, while delta y, as it goes and come back, delta y equals 0. By doing that, we're going to get the velocity at c with the plus minus sign. Obviously, we have to choose the minus sign because it turns out that this velocity, after it comes back, has the same magnitude as the velocity at the beginning, at the point A, but with a minus sign. To find the position and velocity of the ball as it reaches at point T, or at time T equal 3 seconds from its flight. So first of all, we have to start with an initial velocity of VA. This is the best way I can see to solve such a problem. And once we start with the initial velocity of 10 meters, and then the ball is going to go up and then going down again. So we have the initial velocity and we have the time of a flight. So we use the this equation, delta y equal the product of the initial velocity times the time of flight minus half g t squared. By inserting the initial velocity of 10 for the at the starting position of the flight, and inserting 3 seconds for the time of flight, we're going to get minus 15. This means that the ball is going to be 15 meters below the top of the building. So, of course, there is another way of doing it, but it might be longer than this one. You can start from the velocity at point C as well, where we know the velocity, and you can also subtract the time 3 seconds from the 2 we know as it returns to the same level. This is 1 second, and then if we start from here, we're going to substitute time 1 second, and again you get the same answer by using the same equation. To get the velocity of the ball as it goes for 3 seconds flight, let's say at point D, we can do it in different ways, but the best way I can see is to use this equation where we consider the final velocity at D and the initial one at point A, and the time of flight here is 3 seconds. By substituting the values of initial velocity and time, you're going to get the velocity at point D, or after 3 seconds of the flight, is minus 20 meters per second. The velocity has this magnitude. The minus sign means that it's going downward. Another way might be carried out. For instance, we can start from C, where we have a time from C to D, which is equal to 3 minus 2 seconds. The time as the ball goes up and down is to point A, the same level, is 2 seconds. Then 3 seconds of the whole flight minus this 2, going to get time of 1 second. By using the same equation in here to get the final velocity, but now the starting velocity is not at A, at C, and inserting a value of minus 10 meters per second and a time of 1 second, then you're going to get the same answer. Obviously, you can do it by also by starting from B and using the same equation, and you'll get the same answer. But remember, the time of a flight between B and D is going to be 3 minus 1 instead of 3 minus 2. And finally, to find the velocity as the ball strikes the ground, we put the information we have for the initial velocity at A with 10 meters per second positive, as we said, and delta y, which is the displacement as the ball goes from A to E. and then employ the equation, the fourth equation, by substituting v initial as 10 and delta y as minus 30, the velocity at E is obtained with minus sign, which means it is downward, and the magnitude of this velocity is 26.4.